All right, so ASPT 5.1, the biggest objective that we have in this unit, and honestly the most impactful for your chemistry knowledge, because we're looking at how the periodic table is organized, and based on this information is going to give you a ton of information about the electron shells and all that kind of stuff, and how many valence electrons and what kind of ion it creates. I mean, this is the objective. If you need to master anything, you need to master this objective. So you have 7 key components to this objective. So the first thing is understanding that the elements are listed in order of atomic number. So 1 through over 100, they're listed just kind of like your reading book. Number 2, explaining how the atomic mass is affected as you travel right and down on the table, so looking at that mass trend. Number 3, explaining how volume is affected as you travel down the table, so you'll notice we only do one direction. In high school chemistry, you will do multiple directions like you did with mass. Number 4, identifying the locations of halogens, noble gases, alkali metals, and alkaline earth metals. Those are the families that you need to know for this unit. Number 5, explaining why and how elements within the same family, which is also considered a group, have similar physical and chemical properties. Number 6, identifying the most reactive families in groups and what subatomic particle is credited for determining that reactivity. And number 7, using the periodic table to identify the number of valence electrons, electron shells, and ionic charge. So we have quite a few suggested activities because this is a lot of information. The first thing is, how is the periodic table organized? This will give you step-by-step instructions on how to figure out ionic charge, valence electrons, family names, that kind of stuff. So this activity will take you through the coloring of the periodic table, the organization of it. So this is a really, really important activity. How should it react? Starts looking into what determines reactivity and what does it mean to be something react. Reactivity demos, this is something we're going to do together. This is when we will react calcium and magnesium. Also, we'll go outside and we'll do potassium and sodium, and we'll see the reaction of those and try to figure out some trends. The organization of the periodic table practice quiz and the reactivity practice quiz are really simple snapshots, but really making sure that you understand how it's organized and also being able to understand reactivity as well. So big idea questions. What determines how the elements are listed on the periodic table? What are the following trends of the periodic table? So atomic and mass specifically. How can you identify the locations of the following families: halogens, noble gases, alkali metals, and alkaline earth metals? Why and how are elements within the same family or group have similar physical and chemical properties? Which families and groups are the most reactive and why? And can you use the periodic table to identify the following? Number of valence electrons, electron shells, and ionic charge. So when I give you, like for example, the last one, I will be asking you elements that are beyond the elements that we created Bohr models for. So I said we only go up to element 20, which is calcium for Bohr models, but when you know the organization of the periodic table, you can do elements all the way, I don't know, francium. Okay, so francium is way beyond calcium, bottom left-hand corner, and you should be able to do that based on the organization of the periodic table. So let me know if you have any questions. Like I said, it's a very big objective, but the activities do a good job of kind of taking you step by step. And good luck. Let me know.